Hello, hello, and welcome to this video. So we have finished the arrays and objects. Now we will look at the classes of JavaScript. So before we could learn about JavaScript, we have to understand about prototypes and how prototypes-based inheritance mechanism works. That is how you do object-oriented programming in JavaScript. JavaScript was not my first language. I first learned C, then C++, then Python, and then JavaScript. So I had a bit of difficulty understanding the object-oriented mechanisms in JavaScript. So similarly, you might have issues if JavaScript is not your first language. So in class-based languages like C++ or Java, our classes are blueprints, objects are instances, inheritance is a relation between classes. That's what we know as C++ Java programmers. However, if you have not programmed in C++ and Java, then don't worry about all this. We are going to talk about prototype-based inheritance mechanism in JavaScript. So objects directly inherit from other objects. No classes are required. The class keyword which came in ES6 is syntactic sugar over this model of prototype-based mechanism. So the key idea is that every JavaScript object has an internal link to other object. Its prototype behavior is shared by delegation, not copying. So let's look at an example. Okay. So every object has a hidden internal property that is called prototype. Okay. And it is accessible via object.getProperty of obj, where the object is in the question, or the legacy obj underscore proto underscore property. When you access the prop of an object in JS, it looks for prop in the object itself. If not found, it looks for the prop in the prototype of obj, and continues up the chain until it either receives the property or receives null. That is, the prototype is null. Okay, this we already have established in our earlier videos. Now consider this piece of code. We have animal, an object, and it has a property eats following true. So property eats is true. Now we create an object rabbit from animal, and we give it a property jumps is equal to true. Now if you look for eats on rabbit, then it will go up the prototype chain and will look at animal and will see that okay, eats is true. So it will be true. Jumps will be found on the property itself, on the object itself, so it is true as well. Now if you try to get the prototype of rabbit, it will be animal. Okay, so this equality will be also true. That is how prototype works here. Since we created from animal, the prototype of rabbit is animal. Now this is how the prototype chain looks like. Rabbit inherits from animal, animal inherits from object of prototype, which inherits from null. So prototype of rabbit would be animal, prototype of animal would be object, and prototype of object would be null. Now we look at other functions which we have covered. If we look at has own property, then it will not go up the inheritance chain or prototype chain. Jumps is a property of rabbit, which is true. But does the property eats is its own property, then it will be false. Okay. Now, if you iterate over a for loop in this form where you try to find all the keys in rabbit, then it will print both jumps and eats. That means it will traverse the entire prototype chain. But if you look for object.keys only, then it will only give you the has on property. Okay. So foreign walks the whole chain, while object.keys, object.values, object.entries only see own properties. Now as it says, we are going to look at constructor functions and dot prototype. So every ordinary function has a prototype property, an object. It is not the function's own prototype, it is the object that becomes the prototype of instance created with new. Okay. So let's assume that we have a function called dog, which receives a name and assigns the name to this. Now this is the object which we will receive uh, in the prototype chain. It will be clear number. So now we set the prototype dot bark. Okay, whatever is the prototype of dog, we give that an additional property. So this function actually looks at this object of dog. Okay, and it takes the name and says wolf. Now we construct new dog with Rex. Name is Rex. So you see, this function call will call this function and set the name of Rex object. Okay, name of Rex object to Rex. And when the bark function is invoked on the prototype, we see that Rex says wolf. We see that object.get prototype of Rex would be equal to dog.prototype here. All right. So yeah. Now what it actually does is it creates there is a mixture of text between this slide and previous slide. So for example, this one, if you look at, it creates a new empty object O when you do this. Okay. And sets O's prototype to constructor's prototype. Okay. And calls it's not dog with this. It's not dog. It calls constructor. Okay. It applies as we have seen in the previous video. It will bind to object O and call the constructor function. Okay. That is what we do. So now at this moment, object will be created with the arguments. Okay. That is, whatever this constructor is creating, that constructor object will be created. And it returns the result. If type of result is object, then it will return result. Otherwise, if result is null, then it will return O here. Okay. So clearly, you are creating two different objects here. One is O, another is result. Okay. O is your prototype class here. Okay. And it will be created by looking at the prototype of the constructor. And then you apply that with the constructor and arguments. So either result or O will be returned. The log and this does not come here. It is a mistake in typing. Now, if you can create two dogs, A and B, with A and B, and both will bark. Okay. Now, if you see that this bark equality matches, what this means is this is shared, not duplicated. Putting methods on dog.prototype means one function object is shared by every instance. Contrast with defining this.bark is equal to function inside the constructor, which creates a new closure per instance. Okay. So if you create list.mark function inside the constructor, then that will be limited only to that particular object. It will not be applied to the entire prototype chain. For that, we have to assign to doc.prototype. Now we will see some code where we build inheritance by hand. We have animal and we receive an argument name and assign the name to this.name. Now in the prototype, we have a property eat, which is a function object, and it prints this.name each. So whatever is the name will be passed here while constructing the object that will be printed. Now we have another function rabbit name, and we call the animal class here, and we create the constructor object of animal. Okay, so it will set the name of the animal. Now rabbit.prototype is set as object.create animal.prototype. This will set up our prototype chain. And the constructor is rabbit. This function becomes the constructor of rabbit. Now we also add another function jump. So we have this dot name jumps. Now we can create a new rabbit named bugs. And if we call bugs.eat, it will print bugs eats. And if we call bugs.jumps, it will print bugs.jumps. So why we call object.create and not new animal constructor? So rabbit.prototype is new animal. That is the old pattern. The problem with this actually runs the animal constructor just to build a prototype object side effects, wasted work and requires no arg safe constructors. Object.create animal prototype creates an object linked to animal.prototype without invoking animal at all. This is the historically correct way to add a prototype chains before ES6 class existed. Okay, now we will look a bit at the new syntax, which is what you should follow. Okay, so this syntax came in ES6. Now we don't have to worry about all those complicated prototype chains and all, but we'll encounter that kind of code in the legacy code. So we are looking at class animal. We have a constructor just like C++ or Java. We assign the name to this.name, eat is this.name eats. And we can extend the animal class here using the rabbit class extends the animal class. The constructor call invokes the parent's constructor supername. So animal's constructor will be created, and jump is console.log this.name jumps. So bugs, if we create now and we say bugs.eat, still it will print bugs eats. Okay, it still works via the prototype chain. So class these figures the constructor functions plus object.created style prototype linking type of rabbit is equal to function is still true. So what class gives us the class method? This syntax, what does this give us? It extends one of the prototype chain automatically. Super calls the parent constructor correctly. Super.method calls the parent's version of a method. Methods are non-enumerable by default, unlike manually attached ones. Class bodies are always executed in strict mode. Classes cannot be called without new source type pattern. Still, this is not real class. Okay. Now I think I'll stop here and we will cover rest of the this slide in the next video. Okay. So we have covered almost let me see, there is quite a lot of material to be covered, so we will cover this in the next video. Okay, there are 9 more slides are there. Okay, so we'll cover rest of the material in the next video. Meanwhile, what I will do is I will find somewhere to upload this file and share the link with you. Okay, I will have to figure out where can I put this and then share the link. But in any case, the file does not matter. You can pause. There is not a lot of code involved here, so the file is not the important thing. If you focus on the video, then you will understand everything. So the thing which we need to understand is that we don't need to worry about the old stuff anymore. Old stuff is only for legacy code. What we should focus is on the ES6 standard. So this syntax you should be careful about, that how you create how we call parents constructor, and if you have custom logic for the constructor, you can put this here. Okay, and know that what is your own property and what is the prototype property. So all that clarity you should have. So with this, I will end this video here. and we will meet again after 4 days with the rest of the material. So thanks a lot for watching the video. Keep learning. Have a nice day, and most importantly, enjoy.